let's find a few derivatives. And those derivatives are going to involve the product rule or the quotient rule. In this case, it's going to be the product rule, and here's why. We have 6 times the square root of x times cosine x minus sine x. So 6 square root of x times this, but because I just said the word times in there, we're going to be dealing with the product rule. So let's just go ahead and write out what we know. So here's what I know. I know the first thing is 6 square root of x, and I know the second thing is cosine x minus sine x. And if you want to get technical about it, the original function is a g, and then as I define f and g within the context of using the product rule formula, I could say, well, this is g, but this is g. Don't get mixed up with this is g and this is g. This is just a fast way for us to explain the process, but technically this isn't g, this is g, okay? But this just follows the format of the formula. So here we go. We need f prime and we need g prime. I'm going to start with g prime. Derivative of cosine is negative sine. Derivative of negative sine would be negative cosine. There's that. And we need f prime as well, which means we need to find the derivative of 6 square root of x. This is really 6x to the 1/2, by the way. So let's do that. 6 times a half is going to give me 3. Subtract a half. Subtract 1 from a half gives me negative 1/2. So I have negative 1/2. Negative exponent moves it down to the denominator. And because it's a 1/2, it's a square root. So this is f prime. Okay, final answer. Let's use, what color? Let's use red, just because. We're going to do f prime g plus f g prime. So we're going to do this times this plus this times this. Simplify it if necessary. So let's go. F prime g plus f, I'm going to go back to the original, 6 square root of x. They're both correct. This just looks better. Times this. There we go. And we could say we're done, and we are done, but I want to warn you because you might get a multiple choice question like this, and this won't be the answer. So we're going to practice rearranging things, putting things in a different order, dealing with simplification of things like that. Okay, so here's a couple things I noticed. This is a fraction times one big numerator over 1. So if you wanted to, you could say that this is really 3 cosine x minus sine x. And you could say it's 3 cosine x minus 3 sine x. That's fine. Over the square root of x. That's fine. I'm going to go a little crazy on this one. Both of these terms are negative, and so I can factor a negative 1 out. When I factor the negative 1 out, I can put it in the fronty front of that entire term. So it gives me 6 square root of x times sine x plus cosine x. We just factored the negative 1 out. And this is correct. I left a little space here. This is also right. But they might not have this answer either. They might make this one fraction. If you're going to make this one fraction, you need a common denominator, and my common denominator is the square root of x, because this is over 1. So what I'm about to do is go a little old school on you, grab a green marker, and I'm going to say, well, you know what, this is fantastic, but if I wanted a common denominator, I would need it to be, well, square root of x, like I said. So this is going to need a square root of x in the denominator and another square root of x in the numerator. And this square root of x times this square root of x simply gives me x. So I'm going to make one more step out of this. Any of these are correct. I'm just moving forward so you can learn some simplification tricks. So I'm going to bring the work up here. And as I do, I will have 3 cosine x minus sine x. I'm not going to distribute. You can if you want to. Here, my work's going to come up here. So 3 cosine x minus sine x over the square root of x. And I left more space here because now I have a common denominator and I can put them all in one fraction. So I'm going to say minus 6x and then sine x plus cosine x. And this is totally correct. And there's more we could do. There are some people who would say, I don't like that. Why don't we get rid of that square root in the denominator and multiply by the square root of x over the square root of x? And that is fine. You could. I'm good with this. We're going to leave it exactly the way it is. Okay. Let's move on to the next problem, which is clearly going to be a quotient rule issue. And it is quotient rule because, well, we're dividing. So let me write the problem up. Pause this if you need to copy something. And the problem is 2x plus 5, 2x minus 4. All right. 2x plus 5, 2x minus 4. There we go. Okay, let's find, I almost said a common denominator. I don't need to do that. I was back in the mode of what I did in the last problem. What I am going to do, however, is the quotient rule. So let's write some stuff down. I'm going to use red on this part too. So the top I'm going to call f, not to be confused with f, the original problem. So 2x plus 5, this is just my way of keeping up with things. And then g is 2x minus 4. G prime is 2, f prime is 2. And we're going to do f prime g minus f g prime all divided by g squared. There it is. F prime g minus f g prime all divided by g squared. Let's go. F prime g minus f, all of it, g prime all divided by g squared. Okay, if you're looking at this and saying, why don't I cancel some stuff? Please don't, because if you cancel this with this, you'd be left without being able to cancel this with some of this, and just don't, just don't. What I am going to do, however, is simplify that numerator. So 4x minus 8 minus, and we're distributing from both sides here, so minus 2x times 2, so minus 4x. Yes, those 4x's will cancel in a second. 10, negative, so negative 10. And then 2x minus 4. If you want to multiply all that out, feel free. I choose not to. Not worth my trouble. Not worth yours either, to be honest with you. But we can cancel those. So negative 18 over 2x minus 4 squared. So to be clear about it, final derivative is this guy, which is f prime, not to be confused with this f prime. F prime is this. Okay? Let's do one more that's a little bit tricky, that's going to involve some ridiculousness, that involves e to the x. The derivative of e to the x is, yeah, you said it. I hope you said it. If you didn't say it, you're about to find out what it is. E to the x is the best derivative ever. All right, what do we have? We have f of x equals 1 over x minus 2e to the x over 3x. That was a very loud marker right there in the microphone. Sorry you had to hear that. 1 over x minus, what was it? 2e to the x. 2e to the x over 3x. Okay, so you might be looking at this and saying, well, I have two quotient rules going on. And you could say you do. You could be like, yeah, I've got two quotient rules going on. There's one here and there's one here. And that's fine. You can do it that way. I actually choose not to. And here's why. I am going to quotient rule this thing for sure. But for this one, I'm going to just treat it as if it was x to the negative 1. It's going to work perfectly fine like that. So we'll do that and minus 2e to the, 2e to the x. E to the x over 3x. Okay, so final answer, I'm going to go ahead and write it. Okay, not the final answer. But I am going to go ahead and excuse me, write a few things. And what I am going to write is, well, the derivative of f, the f, is going to be, well, the derivative of x to the negative 1 would be negative 1x to the negative 2. And that negative 2 exponent is going to send it down. So it's negative 1 over x squared. So negative 1 over x squared. There's the first term. Now we have to do the quotient rule on this term. Okay? Now, we're going to get to the point that we're going to get so used to what's f, what's g, and we're going to crank them out so fast that you're not going to have to write f and g anymore. And that's fine. Not yet. We're not quite there yet. So let's start writing. And we're dealing with this. I'm going to ignore the negative. So final answer will be minus whatever I'm about to get from this derivative here. The negative is going to be built into the final answer. Okay? If we have a double negative, we'll deal with it later. Wrong color. Not that it matters. Okay. F is 2e to the x. G is 3x. G prime is 3. F prime is, well, the derivative of e to the x is e to the x, but we double it, so it's 2e to the x. Here we go. F prime g minus f g prime, all divided by g squared. Let's simplify this just a little bit. Some things are going to clean up quite nicely. I know in a previous problem, I did not multiply the denominator out. I didn't FOIL it, but I am going to this time. So let's bring this over here. 6, obviously, 6x. Let's put the x before the exponential stuff. It makes more sense. 6x e to the x. And minus 6 e to the x. Can we factor out a 6 e to the x? Yes. Are we going to? Don't have to. All divided by 9x squared. Okay. And that is going to go here. But let's reduce. I mean, let's be real honest. All of these terms are divisible by 3. So divide u by 3. Divide u by 3. Divide u by 3. Not all terms are divisible by e to the x. The 2 in the numerator are. Not all terms are divisible by x. So that's what we're stuck with. This is going to go right there, and then we will be done with this problem. And we'll have 2x e to the x minus 2e to the x over 3x squared. And that's it.